Okay. Hello, everybody. So my name is Melvyn. I'm Principal Product Manager at ClickHouse. And today I'm going to talk to you about what ClickHouse is and what Databricks is and how you can use both of them for real-time analytics. Given we're at the Databricks user conference, I just would like to be sure that everybody knows what Databricks is. So if you could all raise your hand if you know what Databricks is. Okay. Can you raise your hand now if you know what ClickHouse is? Oh, wow. A bunch of people know what ClickHouse is. So surprising. There's still a few people that don't know what ClickHouse is, but don't worry. I'm going to walk you through exactly what ClickHouse is and how you can actually use both ClickHouse and Databricks to do real-time analytics on top of your data platform. So when I talk to my user and customers, most of the time, if okay, so the clicker doesn't seem to work. Actually. Okay, it worked now, sorry. So when I talk to my user and customer, the first thing that comes to mind when I want to describe ClickHouse is that it's an open source project. And this is really the fundamental about ClickHouse is that it has been created a while ago, like over a decade ago, really to tackle one problem. And this problem was how to do web analytics. And ClickHouse was designed for two things: speed and scale. And that was it. Basically, that you need to have like a system that can scale to very large data amount, and that could be extremely fast on top of this data. And in 2016 or around, we open source a project with Apache 2 license, and since then, people use ClickHouse in a variety of scenarios, right? So from real-time analytics to observability to data warehousing. Some people use it to store vectors for some reason, and to do like a lot of weird stuff. Some people even use it as an ETL pipeline. So when you think about ClickHouse, it could be many things, and depending to who you talk, they're going to probably have like a different use case for ClickHouse. But yeah, open source, ClickHouse is open source, and it's a very interesting project developed in C++. If you want to have a look at it, the code base is awesome, and it's a very thriving community where we have a lot of contributors, and we are very welcoming of any pull request to the project. The second thing that you think about when you think about ClickHouse, it's often the speed, right? So ClickHouse was designed for exactly that, to do one thing, but do it very good and very fast. So you don't really put ClickHouse in place when you want to do large data processing or batch loading or batch processing. You use ClickHouse when you want to execute a query and you want to have a response in under seconds most of the time, right? You want to have a very low insert latency and a very low query latency. And ClickHouse is a system that can allow both of these things. So it's really I'm a PM, right? So I like to put things into category. And there is slow things, right, that are designed for large scale and large data processing, and there is fast things, which are designed for running query very quickly, and ClickHouse is one of the systems. So there is two use cases that people are using ClickHouse for. The first one is real-time analytics. So you store data into ClickHouse, and you want to have a query to power a dashboard, to power your application, and you want to be extremely quick. And this is one of the use cases. The second use case, which is also very popular, is around observability. And you could argue that observability in a lot of scenarios is actually a real-time analytics problem, right? You collect a bunch of data, and you want to be able to know what's happening into your system extremely quickly. So this is why a lot of people are actually using ClickHouse for real-time analytics. And we have people like Anthropic, Tesla, Netflix that are deploying ClickHouse at very large scale for these exact purposes. So how did we make ClickHouse fast? And this is important to understand because it goes back to the fundamental of how we develop ClickHouse. And a few things that we spend a lot of time working on. And the first thing that comes to mind is the native ClickHouse format. So this is how ClickHouse actually stores data on disk and how ClickHouse as a query engine interacts with this stored data. And we spend a tremendous amount of time, so it's important to highlight that it's column-oriented, very similar to Parquet. And the way it works is that ClickHouse will, by default, sort your data on disk automatically. So you specify a specific key, and when ClickHouse will insert data, it's going to sort this data in memory, and then it's going to write them on disk using your specific key. And when we write this data on disk, we actually create a sparse index, which we load then in memory to have like a very low query latency. We can actually use this sparse index to scan through your data efficiently and skip a lot of data given the index is sparse and your data is sorted. It allows ClickHouse to be extremely fast if you are querying on your sorting key. So that's one aspect where we spend a lot of time when developing ClickHouse. The other one is around making sure that ClickHouse could have a good insert throughput. So when you insert data into ClickHouse, it creates data parts. These data parts, over time, get merged together into large data parts, and larger until it reaches like a very large size. And then we stop merging them at some point. But overall, ClickHouse has this very similar concept than Delta or Iceberg has, where we have a bunch of data, and then we compact them, we optimize them over time. But ClickHouse do it extremely aggressively. It has like a variety of algorithms to do this merges process. And ClickHouse really try to optimize this merge algorithm a lot. And then there's a lot of feature around this, this native format that we've developed. We've implemented asynchronous and synchronous materialize view in order to pre-process your data as you insert them into ClickHouse or process your data at a specific time interval. And that helps a lot when you are doing to reduce your query latency when you are querying data. We also use ClickHouse a lot to develop many different data types, because the more data types you have, the more various your workload is, the more you will need to build internal data structure to support your workload. And when you have like a columnar storage and you want to optimize on top of this columnar scenario, you need to have the corresponding data structures that help you leveraging all the existing index and data structures that you have in ClickHouse. So we develop, for example, JSON objects. How do you develop a JSON object in a columnar format? That's a complicated topic, and we want to make sure that whenever we introduce a data type in ClickHouse, we support it for its native format very well. And it's also important to understand that ClickHouse is also distributed by design, right? So when ClickHouse is being deployed, it's deployed in a cluster. So you have like multiple nodes. Each node can read a subset of your data when you execute a query. And each node actually has multiple CPU that can process chunk of data independently. And your CPU actually can leverage SIMD instruction to speed up the processing of this row. So we actually build a vectorized query engine that can use every component of your infrastructure. And on top of that, because ClickHouse is developed on top of Object Store, you need to make sure that you have a very advanced caching layer, because the worst thing with Object Store is latency, right? And especially the tail latency. So you need to make sure that your query engine is very good to query your Object Store, and then there's a lot of ways of implementing solution for it. You can have like very aggressive retry mechanism. So you basically have ClickHouse always retry reading from specific files in your object storage if they don't respond at a certain speed. There is also the caching layer. So each compute node in ClickHouse comes with its own attached SSD, where we can actually load parts of the data parts that are stored in your object store when you insert the data or when you query them. So allowing you to, instead of going directly to the object store, you can actually go through the cache, and you have like a very low query latency. So this is all optimization that we developed to work on top of our own native format. And at this point in time, you are telling me, well, how does that work on top of my data platform now? And this is what I'm going to talk to you about. If you want to learn more about ClickHouse, we wrote a white paper, super interesting if you are interested in computer science, information retrieval. It goes into very detailed explanation about how we build this different data structure that ClickHouse is leveraging to create its own native formats. But today, I'm here to talk to you about how we actually integrate with a data platform. So as a OLAP system, and ClickHouse is a OLAP system, you want to make sure that you integrate with the rest of the ecosystem that your users are using, right? Because we know that OLAPs is not a single silver bullets that can address any scenario. We know that our customer have Q somewhere, right? They have like RabbitMQ, Red Pandas, Kafka, even though it's very difficult to work with Kafka sometimes. We know that our customer and user are using it. So we need to make sure that we can integrate with it, right? We need to make sure that it's easy for a user to load data from Kafka to ClickHouse. So we develop query, we develop, table engine for that. So just a simple table engine that connects to your Kafka topic and can read the data from your Kafka topic and insert it automatically into ClickHouse just via SQL query. So that's one thing that we do, right? But then there is people that are using OLTP database. On the right, there is a lot of scenarios where you need OLTP database and you must store your data in a transactional way. And ClickHouse also integrate with this OLTP database. We have like CDC pipeline to make sure that we can actually read your data into your OLTP database and load them into ClickHouse, and keep these two tables in sync, making sure that you can use your MySQL, PostgreSQL database for transactional workload, but when you need to do analytical workload, you can use a proper system that will give you the performance that you want. And of course, like one of the biggest workload is probably data lake. But today, like every company probably is using S3 to store data. It could be in iceberg format, it could be in Delta format, it could be in S3, it could be in Parquet file, it could be in JSON file, some people store CSV. So we need to make sure that we can actually also integrate with this ecosystem. And here it becomes a bit more complicated because you need to start supporting many different data formats, right? So you support ClickHouse native formats, and then you need to support Parquet file, and then you need to support JSON file and CSV file, and then you need to start like developing a complex query engine. And today I'm going to talk to you about how we did it for Delta Lake in particular, because I think there is a lot of development that has been happening in that space that made this integration very good. So before we develop this integration, I talked with a lot of customers and users and asked them, like, how do you use ClickHouse on Databricks? Or how do you use ClickHouse on your Delta tables? Or how do you use ClickHouse on your iceberg table? And often, the architecture that came back was this type of architecture. So depending on the customer, like they have different workflow, some people do dual writes. So they insert both into ClickHouse, they insert into their iceberg table, or Delta table, or UD table, or Parquet file. And then, they have like a specific TTL policy for the data in ClickHouse. So maybe after 2 weeks, 3 weeks, the data in ClickHouse get removed, and they keep the data in Delta or iceberg for 1 year, 6 months, like depending on their requirements. And I think, for example, Netflix is doing that at very large scale. They did a talk recently where they talk about how they insert like petabytes of data into ClickHouse and in iceberg, and then when they are using ClickHouse and when they are using iceberg for the different type of query. It's a super interesting talk if you are interested. I highly recommend it. And then you can actually use ClickHouse. The good thing is that if you support correctly your data lake, you can actually use ClickHouse for your storage, but also to send query to your data lake if need be, right? So maybe your team is always using ClickHouse, but sometimes if they have like, I don't know, they need to do RCA and they need to access like cold storage, then they can still do it from the same system. So when we come to that conclusion, we thought about, okay, so we need to support Delta Lake, we need to support Iceberg, and we need to support Parquet. So we started like building all this implementation, and funnily enough, like us as a company, ClickHouse, we're a company, we didn't initially invest in it. It's actually our user that did it, right? Because they're using Delta Lake, they're using Iceberg, and they want to use both of them at the same time. So the first pull request was done by the community member, and it was initially introducing Delta and UDI table engine that could, read Delta and UDI table on top of S3. That's great, right? And then people start using it. It's merged, it's released, people use it, and they have fun. And then it become more popular. And as it become more popular, like things start to break, right? Well, Delta changed its protocol, so now the table engine doesn't read properly my table engine, right? Or like using a specific Delta feature that is not supported by my table engine because the development of the table engine doesn't follow the evolution of the Delta protocol. And things get complicated because now you have the same problem with Iceberg, you have the same problem with Parquet, and you have all the same problem with all these different formats. So how do you tackle this problem? Well, we actually tackle this problem via two different roads. The first one was, how do we make this delta table, iceberg table, discoverable easily from ClickHouse? And we do that via the integration with the Unity catalog. I'm going to walk through how we did it with ClickHouse and some of the gotcha that we had. But the most important and most interesting topic is probably around how we start supporting better delta table, right? How do we avoid things to break randomly once the delta protocol evolves? And we tackle this problem using something called the Delta Kernel. I don't know if anybody is familiar with the Delta Kernel. Yeah, a little bit. So for people that don't know about the Delta Kernel, is that it's an initiative that was open sourced and that was led by Databricks and Microsoft. It's a project that basically aim at providing library that you can embed into your software that will basically understand the Delta protocol for you. So it will read the Delta protocol, it will parse the file correctly, and it will provide you with the right rows to read. And the complex thing is, how do you do it for any system? Because everybody has their own query engine, everybody has their own optimization. So you need to have an implementation that is good enough to be for everybody, but that is not too specific, right? Because if you start specifying how you need to read a Parquet file, then all these softwares that are optimized for Parquet reading, cannot use your software because they're like, oh, yeah, but your Parquet reader is suboptimal. So it comes in two flavors. Like the Delta kernel comes in two flavors. There is one Java library and there is a Rust library. And basically the way it works is that it provides you with a set of APIs that can help you plug your own readers, and you can you can indicate to the Delta kernel which table you want to read from, right? And you can have basically an interface between your client library and the Delta tables itself. And the tricky thing is that we are a C++ database, and our library, there is no C++ library. There is no C++ library, generally speaking. Nobody likes C++, it seems. We had the same problem with Iceberg. We had to create our own library. And for the Delta kernel, it comes only in Java and Rust. So what we had to do now is we had to embed like a Rust library into a C++ software. It's not trivial, especially when you have like a very complex CI/CD as ClickHouse. It's getting hairy. But in the end, we did it, and it actually simplified a lot of your story because using the Delta kernel, we can actually pass to the Delta kernel our own Parquet reader, our own JSON reader, and the Delta kernel is going to leverage this reader to process the Delta protocol, and it's just going to give us objects that we just need to iterate on to get the correct rows that we are querying. So basically, you can see as the Delta kernel just providing us black box with a way for us to iterate on this black box and get the expected result. So we integrated with the Delta kernel, and it actually helped us a lot develop the integration with Delta Lake, because historically speaking, it was developed by the community, but now you have like all this evolution of the Delta protocol, and then we need to start maintaining it. And it was very challenging for us. With this Delta protocol, I can have engineers that just integrate with the library and make sure that we provide the right reader to it, and we just need to support a set of APIs rather than re-implementing everything from scratch, which help us a lot in terms of supporting a large ecosystem. So I think we integrated with the Delta kernel maybe a couple of months ago, and from there we were able to quickly start supporting like some Delta specific feature like partitioning, pruning, schema evolution, and then we are on the way to start supporting write to Delta table using the Delta kernel, and then we'll expand to statistics pushdown and time travel, and it makes it much more easier and faster for us to start working on top of this integration. So that's one integration that we did with the Delta kernel. the second integration that we did was around the Unity catalog. So once you can read a Delta table, and if you take some, probably like you're all Databricks user, I don't know how many Delta tables do you have in your environment. It's probably a lot, right? And if you want to plug an external system to your Databricks environment, you want to be easily, you want to be able to easily use any table in your environment. So by integrating with a Unity catalog, it's basically just a layer, an API layer that can tell us what table do you have in your environment, what table do you have access to, first of all, and which table you can read. And when you read it, it can actually provide you with a path to where these data are stored. It can provide you with a credential to read these corresponding tables. So it helps us with exploring your data directly from ClickHouse or directly from any query engine that can integrate with Unity REST specification. And the good thing is that Unity is open source now, so the specifications are also open source, and it makes it much more easy for any query engine to actually integrate with the Delta table or uniform table. So today we are supporting two APIs. We are supporting the API for the Delta table, and we are also supporting the APIs for the uniform table. So in Databricks, you can create uniform table, which add a layer of metadata for Iceberg support. So you can actually interact with the Unity catalog using a Iceberg client directly, which allows you to use more query engine on top of your Delta tables. And one of the good things that the Unity catalog is implementing is around credential vendings. You know, in a fully managed environment like Databricks, if you're using Databricks to read your data, it makes security much easier, right? Because you are in control of the whole chain of trust about who can access what data, because you control the query engine, you control the storage. So you make it very easy to know who can access your data. When you start opening it to external query engine, then the chain of trust is broken, right? Because an external query engine could have like logic, that you don't trust typically. And the way it works in Databricks and more, like with the Unity catalog, but it works also with other, I will say, REST catalog, is that it will have the concept of credential vending. So when your query engine is connecting to Unity catalog, basically what's going to happen is that your Unity catalog is going to generate specific tokens based on the permission that you gave to the user. So your user is going to say, oh, I want to read this table. So Unity catalog is going to say, check the permission of the user. So you say, okay, you can read this table, and I'm going to generate a token for you, so you can actually use this token to read only specific file in your object store, right? And it makes it secure, and it makes sure that an external query engine only have access to the data that it has a right to access. So overall, with these two integration, it allows you to integrate with your data lakes in many different scenarios, right? So the first scenario, and I will say like this is for the people that don't like necessarily open table format, is like using Parquet file. So a bunch of people are using Parquet file, or they're using Delta tables, and they're just doing append-only scenario, and they're not leveraging the metadata, they're just leveraging the Parquet files directly. And with ClickHouse, we have a Parquet reader. You can read your Parquet file directly from your tables. The second scenario, and this is when you want to optimize for performance, is you actually read the Parquet file, but you don't query it directly. You actually insert it into a ClickHouse native format. So you are going to insert it, and you are going to benefit from all the performance I've highlighted previously, the ClickHouse native format, all the optimization, all the data type that it comes with. And this is when really you want to have like a very low query latency on top of your object store. The first scenario is a CDC pipeline. So instead of just doing a one-time batch loading, you actually, in ClickHouse, you can create a table engine called S3Q or Azure Q, which is basically a table engine that will connect to your S3 buckets or Azure buckets, and it's going to monitor for new file. And whenever it sees a new file, it's going to load it into ClickHouse, and then you have like a very no-code CDC pipeline on top of your Delta or Iceberg table or Parquet file. And then you have like more complex scenario where you start going through the iceberg and delta table directly. So you can query your delta table directly because it's going to be able to fetch the version int of your tables or the latest metadata, and it will be able to process your table. And the last one, which is going through the catalog, which is the simplest and I will say the most permissive one. So I'm going to show you some of the benefits that it brings to actually have this integration of ClickHouse with your Unity catalog. So first of all, I'm going to show you how you can do that in ClickHouse. So ClickHouse, oh, I need to stop sharing. I'm going to pull out a terminal, so that's very, very interesting. So ClickHouse has a client, a terminal, so I'm connected to my cloud instance right now. And yesterday night, I created this connection with my catalog. So I can actually already start querying. I don't see my, it's going to be interesting. So I can actually show there is no subtitles, show database. Okay. Did the query run? Sorry. Oh, so actually you can see the different database that I have. So I have two databases. So I have more than two databases. I have the default database, which is the default database in ClickHouse, where you can actually store your ClickHouse data into ClickHouse native formats. Then you have like the system database, which are system database basically containing like information about all the metrics that ClickHouse generates for observability purposes. And then you have these two databases, which are the ones that are interesting for us. So we have Unity Demo and Unity Uniform. So that's two different catalogs that I've created, like integration with my catalog. One which is monitoring the endpoint for my uniform tables, and the other one which is monitoring my endpoint for my Delta table. So I can actually check the Unity Demo one, so I can do a show create. Hopefully I can. I don't see the. Yeah, maybe that's what I'm going to do. Okay. Okay, perfect. Thanks. Thanks for the tip. So we can do show database, and then I can select my Unity. Let's take Unity demo. So actually, this is how I created my database. So you can see here, it's very simple. You create a database, Unity demo. You see the engine, so catalog. As you can see, this is my Databricks environment with the specific endpoints that I'm using to connect to my environment. And then you can specify your warehouse. So you can define a default one, or you can use whatever warehouse you have. And then you specify your catalog credential. So here we support like both personal access token, or you can specify your principal key and principal secret, and then create a token. And then you can specify catalog type. So we support different type of catalog. We support Unity, we support Glue, we support Polaris, REST catalog, every catalog you can imagine. Even I've Metastore. So you can actually create different type of catalog and integrate the same way. And then using this database, you can actually start querying it, query your Delta table directly. So I'm going to show you something very quickly, which is on my other screen. And this is something interesting is that using, so you can see here, it's connected to my catalog. You can list all my table. But something I want to show you is around AI agent as well. So ClickHouse has agentic AI, and we have like agents in our next to each database, and you can actually use it to ask him to investigate or analyze your data for you. So yesterday night, I actually asked the agents, well, I have tables somewhere. I didn't specify if they were in Databricks, if they were in my AWS Glue environment, I say I have data about Stack Overflow. And I've collected a bunch of posts from Stack Overflow, and I want to know what's the trend about ClickHouse, for example. And my AI agent is going to receive this request and is going to start looking up at all the tables that I have in ClickHouse. And because we have all this catalog integration, it can actually connect to your Databricks environment and also read the data that you have in your Databricks environment. So if you have like your catalog defined in ClickHouse, your agent will be able to find this table and actually query them to start generating analytics on top of it. So here, for example, it's actually telling you what it's trying to do. It's going to start like trying to display all the tables that you have in your environment, and based on the metadata that you have in your table, it's going to say, oh, I see that you have this table about Stack Overflow, and it's in this database, which is actually the Unity catalog. And then it's going to be able to fetch the information directly in my Databricks environment and eventually federate them with the data I have in ClickHouse. So I have like a centralized place to actually query multiple systems. And given ClickHouse can also integrate with your MySQL or PostgreSQL database, it can really open up the ecosystem and the data reach that your agents actually have, right? And the good thing is that you can also control what the agent has access to, because you can control the permission at the catalog level. If you don't want the agent to see some data, you can just not giving the agent the right permission to have access to the data you don't want them to access. So you can see them actually running queries and thinking. He actually sometimes fails some queries for some reason. But then he finds the right table and he starts like doing SQL queries. He's doing a bunch of SQL queries. I didn't want to do it live because, you know, like seeing a bot running queries is not the most thrilling thing. So I asked him to generate a report, and at the end you can see that directly from a single place, he was able to federate all the data that I have that he has access to, and kind of generate me a small summary of, you know, where ClickHouse is mentioned in Stack Overflow. So he checks the body, he checks the tags, he checks the title of the question on Stack Overflow, and then it can generate graphs. So this is the number of comments that mention Stack Overflow. This is a post that mentions Stack Overflow. This is the answers that mention ClickHouse, sorry. And it kind of generates your graph, and it can actually start giving you analytics. It's good. So it says, for example, there is more questions than answer, but most of the time there is at least one answer per question, which is good. It means that there's a healthy community that actually help our ClickHouse user, even in the open source. So yeah, so this is, so you can see at the end, it gives you like some key takeaway that you can have, what type of tag, you know, ClickHouse is using alongside. And surprisingly, you know, like the most popular one is SQL. You know, ClickHouse is a SQL database. So yeah, you can see there is database, Python, Docker, ClickHouse client, which is the one I showed you just before, like from the terminal. So yeah, you can see how ClickHouse is kind of connected to the ecosystem. And then it gives you like final key takeaways. So that's just a way of showing you that, you know, like by building like good integration with specific table formats, and by building integration with catalogs that kind of display and give you access to more data, then it makes any workflow better, including agentic AI that can actually scan a much larger data footprint and giving you the insights that you might want. Great. So I think that's my last slide. Let me go to the presentation mode. Okay. I just did it. And yeah, if you have any question, I would love to take them. There is a question.